The question that remains is how to rank the four factors. For example, imagine that we are comparing the following two compounds. If we wanted to know which of these compounds is more acidic, we would have to draw the conjugate base of each and compare them. The conjugate base of hydrochloric acid is Cl-, and the conjugate base of acetic acid is the acetate ion. Now, if we were to compare these two to each other, what we see is that factor number one, what atom is the charge on? A negative charge on chlorine is going to be more stable than a negative charge on oxygen. Why? Periodic table looks like this. Now, it's true that oxygen and chlorine are neither in the same row nor are they in the same column, which are the two trends we saw when we looked at what atom the charge is on. However, we know that if we were to compare oxygen and fluorine we're comparing in the same row, and therefore the dominant effect is electronegativity. So F- is going to be more stable than O- because of electronegativity. We also know that when you're comparing in the same column of the periodic table, size is the dominant effect, which means that Cl- being larger than F-, Cl- is going to be more stabilized. Even though fluorine is more electronegative, chlorine is larger and can better stabilize the negative charge. So if Cl- is more stable than fluoride, if Cl- is more stable than F-, and F- is more stable than O-, then certainly Cl- is more stable than O-. So when we compare these two conjugate bases to each other, factor number one, what atom is the charge on, factor number one tells us that we should go with chloride. Chloride is more stable than acetate because of factor number one. But now we look at factor number two, and factor number two tells us that the acetate ion has resonance structures. O-. In other words, saying the acetate ion, the negative charge is spread out over two oxygen atoms, as opposed to here where chloride, it's stuck on one atom, on the chloride. So according to this argument, the acetate ion should be more stabilized than the chloride. So factor number two, resonance, tells us that the acetate ion should be more stabilized. So which one of these factors wins out? Which one is the dominant factor? Is it better to have a negative charge on a chlorine atom, which is more stabilized than an oxygen? Better to have a negative charge on chlorine than oxygen? Is that more important? Or is it more important to have a negative charge spread out by resonance? And the answer is that the order of the four factors in general is the order of priority. In other words, saying what atom the charge is on is more important than resonance. It is better to have a negative charge on one chlorine atom than to have the negative charge spread out over two oxygen atoms. And therefore, this is the factor that wins the day. What atom is the charge on? Chloride is more stable than the acetate ion, and therefore HCl is a stronger acid than acetic acid. In fact, it is significantly stronger. HCl is a very, very strong acid, and acetic acid is a very, very weak acid, relatively speaking. So in general, the order of the factors are in the order of priority here, and there is one notable exception. If we compare the following two compounds, acetylene and ammonia. If we want to compare these two compounds to each other and ask which is more acidic, we need to draw the conjugate base of each. Conjugate base of acetylene, we're going to pull off that proton, and we're going to end up with the acetylide ion. And when we pull a proton off of ammonia, we get an amide ion, negative charge on the nitrogen. If we want to compare these compounds to each other and ask which is more acidic, what we really need to do is compare this conjugate base to this conjugate base and ask which is more stable. So we do that with our 4 factors, and we start by looking at the first factor, and we see what atom is the charge on. So here the charge is on a carbon atom. Here the charge is on a nitrogen atom. Remember, the periodic table looks like this. And nitrogen and carbon are in the same row of the periodic table. And when comparing 2 elements in the same row, remember that the dominant effect is electronegativity. Nitrogen is more electronegative than carbon, and therefore N- is going to be more stable than C-. That suggests that the amide ion should be more stable than the acetylide ion. However, if we look at the remaining factors, we see that factor number 4, what orbital is the charge in? Here, the charge is in an sp hybridized orbital. Here, the charge is in an sp3 hybridized orbital. So if we look at what orbital the charge is in, we said that it's better to have a negative charge in an sp hybridized orbital because the negative charge is closer to the nucleus of the carbon atom. And therefore, this factor suggests that the acetylide ion is more stable than the amide, whereas factor number 1 suggests that the amide ion is more stable than the acetylide ion. So we have, once again, we have 2 factors in competition with each other. This is the exception to the priorities of these 4 factors, 1, 2, 3, 4. Yes, in general, factor number 1 will beat out the other factors. However, in this particular case, this is an exception where factor number 4 actually beats out factor number 1. Factor number 4, what orbital is the charge on, in this case is more important. It turns out that having a negative charge in an sp hybridized orbital is more stable than having a negative charge in an sp3 hybridized orbital, even though the negative charge here is on carbon. Even though we're comparing C- and N-, nevertheless, this is a case where C- is more stable than N-. So to recap, anytime you have 2 compounds and you want to compare the acidity of those 2 compounds, what you have to do is draw out the conjugate base of each and then compare these conjugate bases to one another and ask which is more stable. For doing that, we use the 4 factors, and we use them in this priority. What atom the charge is on is more important than resonance, which is more important than induction, which is more important than orbital. And the one exception is this case here. A terminal alkyne is actually more acidic than an amine or ammonia. The following skill building exercises are designed to help you recognize these 4 factors when comparing the acidity of 2 compounds.